Hello, this is Miss Sharp from CHS doing my first virtual lesson for you guys. So we are going to go ahead and move on to the next unit, which is actually kind of interesting because with all this COVID-19 thing, they've been showing like graphs and such, and they've been calling it exponential. That's actually what our next unit is all over. So we're going to actually talk about exponential graphs, which actually follows a nice trend with all this crazy coronavirus stuff that's going on. So there are two different types of exponential functions. There's a growth function, which is what the coronavirus is following. And typically when you look at an exponential function, there's really kind of three parts. You can have a coefficient, so that's what this a is. It's just a constant number that could be in front of it. We have the base, so that's why we a lot of times use the letter b for that, because the base, what it has is our exponent, which now is a variable. So typically up to this point, our exponents have been just regular whole numbers, or sometimes we even could work with decimals or different things like that. But in order for it to be exponential, you have to have a variable that's an x of some sort. Now it can be more than just x. This is kind of the basic function. So we can put all numbers in around the function, and you'll see that in my examples. But again, we have two types: growth, and that's typically when the base is bigger than 1. So like 5 to the x, 6 to the x, something like that. And then we have decay, which means it's decreasing. And so usually you'll see a base as a fraction for that. So here's a couple examples. There's actually 4 different types of graphs that you can see with it. So with our growth, another word we can use for that is increasing. So if you look at the graph, if you follow along like you read a book, you go from left to right, it should go up. So here's 2 different ways it can do that. Now sometimes it starts down, kind of at a level part, and then it jumps up. And that's typical of an exponential graph. Usually there's one part that's pretty leveled, another part that's jumping up or jumping down. Sometimes the increasing graphs can start with a big jump and then eventually level out. But again, if you follow each one of these graphs as they go from left to right, it's following the trend of up. Okay, again, whether it's leveled at first and then jumps up, or it's jumping up right away and then kind of levels out, that would be our growth graphs. Okay, so like I said, typically that's what a growth function would look like. That's, like I said, it's not either one of those. Then for our decay, which we also call decreasing, it's kind of the opposite. So it looks like it's going down as you read it from left to right. So like I said, you have 2 options. It can be going down a lot to start with, and then kind of level out, like this first graph. And it could also have ones that are pretty level to start with, and then all of a sudden it drops down. Okay, so that's what a decreasing or a decay graph will look like. And like I said, if you look at all these, what's typical with exponential graph is one side of it is usually leveled, and the other side is either shooting up or shooting down. So you'll see that as a typical exponential function. Alright, so now we've got a couple of terms we're going to talk about. Like I said, the first equation I put up there was kind of basic. It was kind of the basic exponential graph. But we can actually put numbers all around our base. Again, what makes it exponential is that base has an exponent that has some sort of x in it. So that's what this is showing, is it's just there's all kinds of places we can put numbers. Like I said, typical graph has that leveled part. There's actually a word for that. It's called an asymptote. We'll talk more about that later, but I like to introduce that phrase as an asymptote. So there's a part where the graph levels out. What that means is that the graph's never going to go beyond that point. So it's a value that's approached but never crossed. So it's going to hit that and it's not going to cross it. So again, it's going to continue to shoot out. And even though it kind of looks like it levels out, it actually is moving ever so slightly. But again, it won't go past that point. So that's called an asymptote. We've talked about domain before. So typically with domain, it's your x values. It's how far left and right the graph goes. If you look at all of our graphs, they don't have arrows, but typically they're going to do, if you zoom out a little bit, they're going to keep going. So the graph never stops going left. And actually, as it's going up, it never stops going right either. So the domain is not restricted. So that's why we're going to say the domain is all real numbers. And that actually doesn't change because there's never going to be time, or if you look to the left of the graph or to the right of the graph, that it's going to stop. So it's going to keep going forever. So every single time our domain's going to be all real numbers. Now I do accept an abbreviation for that. So if you want to use the abbreviation ARN for all real numbers, I'm perfectly fine with that. But domain for the graph is going to, since we're looking at values, since now there's a little bit of restriction now that we've created an asymptote, domain still has no restrictions. Your graph's always going to go all the way left to all the way right, so it's going to be all real numbers. Now your range, that's your y values, it is affected. So it's going to be greater than the asymptote, or sometimes it's less than, and we'll talk about that in our examples. But again, what restricts the range is because y is up and down. The graph does not go up and down forever. This is going down, but as you're going up, it kind of stops here where it's leveled, and that leveled spot is the asymptote. Same thing for this one. This one stops going down at that leveled part of asymptote, but it does continue going up forever. So there is a restriction on the range, and that's always the asymptote. Okay. So for our graphs that we're going to look at, I'll upload a Google Doc for you to graph and snip, and then there'll be several parts. We're going to do several examples now. So you're going to graph and snip on Classroom, so you're going to use the same snipping function that you've used in the past. You're going to state the domain and range. Like I said, domain is always all real numbers because there is no restrictions left to right on the graph, because if you look all the way left and all the way right, the graph never stops. And the range, though, has that restriction. It is going to stop at that asymptote. You're also going to say whether it's growth or decay. So again, growth is your increasing function. Decay is your decreasing function. So if you're, as you read the graph, like you read a book from left to right, if the graph's going up, then it's going to be a growth function. If the graph's going down, it's a decay function. And the other thing we're going to do is, we've done this in the past, x and y intercept. So I didn't put those in my vocab things, but again, we've done that before. You should always have a y-intercept. That always happens. There are some graphs that do not cross the x-axis. If that happens, just say none. So we've had that in the past too. So again, you should always have a y-intercept, but your x-intercept, sometimes the graph doesn't cross that, so you'll just say none. So let's look at our first example. I already have it pre-snipped, but I am going to show you in Desmos just a couple of reminders as we go through it. So the first graph is going to be 5 to the x. So remember, to get to the exponent, there's the online keyboard you can use. This gives you any exponents, this a with a little b, or you can use the quick key function, shift, and the number 6, and that'll get you that exponent of x. So that's my first graph. So then to get a good snip, what I'm looking for, I'm going to highlight the point, because that does a good job of highlighting where it crosses the x and y axis. In my snip, I want the x and y axis, and I also want a good portion of the leveled area, and then where it jumps up. Okay, so you'll see that in my snip that I have on my screen back here. So again, for a good snip, and I will be looking for good snips, I have a leveled area here, and then it jumps up. And again, I can see my x and y axis in the snip. And again, if there's a point, go ahead and put that there. Okay. So that's part A. Part B is domain and range, which you can abbreviate that to D for most of it. But for domain, like I said, if you look at this graph, it never stops going left, it never stops going right. As I zoom in and out, okay, and the graph's going to continue to go, even though it kind of looks like it's leveling out. If you look at the x value, it is still going on and on. So the domain is not restricted, because the graph's going to continue going left forever and right forever. Again, it's very steep here, but it does keep going right. So the domain is all real numbers. or you can use the abbreviation ARN if you want to abbreviate. And again, that's something that remains consistent no matter what. The domain will always be all real numbers, no matter what, okay? So that's just kind of an easy point there, because again, it's not restricted. It continues going left and right forever, so the domain is always all real numbers, but whenever we're analyzing domain and range, we have to do both. So the domain will stay the same every single time. The range is what's going to change. That's up and down. And again, since range is y values, we're going to use the letter y. So again, that does how it's going up and down. This graph does not go down forever, okay? So it's going to go down until it levels out, which is kind of right along that x-axis there. So that's going to be 0. So I'm going to say y is greater than 0. So again, if you look at the graph, it's all above that 0 value. So that's how we list out our range. C is whether it's growth or decay. So if you follow the graph along with your finger, read it like you read a book, you're following along, it's going up as you go along. Again, it's not really moving much at first, but as you keep following it, it does jump up, so that is a growth. And then the last one, x-intercept. It does not cross the x-intercept, so for my x-int, I'm going to say none. And that y-intercept, I pulled that point, it's at 1. So there is my first example. So I'll give you a chance to look at that. Adjust my snip a little bit. So again, the domain is always all real numbers, no matter what. That does not change. Range, it should be y is greater than, and then wherever it levels out at, just kind of estimate that from the graph. So it's 0. It's increasing as you follow it from left to right, so that's why it's growth. It does not cross the x-axis, so the x-intercept is none, and then it crosses the y-axis at 1. So here's our second graph. Again, I have it in Desmos. To get the fraction, what I did, just use the divide. Now once you get it into the fraction, it kind of will stay, the cursor stays down there. So if you just hit the right arrow, it'll get out of it. Do make sure you put the parentheses around it. Typically if there's parentheses typed, make sure you put those in. So that way it reads it all correctly. So you shift 6 to get your x up there in the exponent, and then the +1 later. And again, if you look at the graph, there should be just one point here, because this graph kind of levels out here right way above the x-axis, so it's actually not going to cross that. So again, in your snip, get your x and y-axis in there, get a good portion of the kind of jump part and also the level part. So that's our snip. Domain is always all real numbers, okay, because there's no restrictions left and right. But again, since we're analyzing the graph as far as its values, we always have to do both because they have domain and range. So the domain never changes. It's always all real numbers. Again, if you don't like the abbreviation, you can write it out. Again, range is always y. And I just throw a greater than in there. Sometimes you can switch it to a less than, but I'm not going to be super picky on that. I just want you to figure out where it's leveled out at. So if you look here, it's leveled out here, which I would say that's about 1. Okay, so that's y is greater than 1. Here's your helpful hint. Where else do we see 1? Right up here. Okay. Usually if there's a number that's added there, that's usually your asymptote. If you look at the last example, there was nothing added there, so our asymptote was at 0. But here, there is a number added there, and if you look, that is right at 1. Because here's 2, and it's in between 0 and 2, so that has to be 1 right there. So just a helpful hint. Again, you can always estimate it from the graph, but again, that is a nice little clue of what it should be. So So there's our range. You follow this one with your finger, it's going down. Okay, so when we say it's down, it's decreasing, that's called decay. Again, this one's never going to hit the x-axis because the level out above it, so there is no x-intercepts, and the y-intercepts, they're at 3. So there's the second one. Next one, this one's a little bit different because this one's flipped upside down. The thing that changes about it is there's this negative in front. So if there's negative in front, it does flip it. Also, if x happens to be negative, that's another place it'll flip it. Again, if you look at the graph here, again, we've got that leveled area. This time it's up at the top of the graph, and then it jumps down. Okay. Again, as you highlight points, this one actually does cross the x-axis. There's 2 points to highlight. So when we get to part D, we'll actually have an x-intercept with this graph. Okay. As far as typing that in, nothing unusual. Just make sure again to get that exponent, shift 6, or use your online keyboard. That's part A. Part B, domain, again, always all real numbers. I'll just use the abbreviation here. Range. Again, this one is one that you could switch and use less than. So if you look at it, it's going down. So I'm actually going to put a less than with this one. And it levels out kind of up here. Here's 4, it's one more, so 5. Again, that number usually is where your asymptote's at. So there's 5. If you follow the graph along, this one looks a little bit different than this last graph, this example 2. But if you follow it, it's leveled and then it shoots down. So that is another decreasing one. So this is another decay. I'm going to do part D over here. This one I actually do have an x-intercept. And I'm just going to put 0.368. And then my y-intercept is 2. So there's that third example. I do have one more example that I want to talk about, just because there's one slight thing that you can see when you type it in. So again, I'm giving it a second to look that over. Again, domain is always all real numbers. Range is y always, and if you put a greater than, this is a less than, I'm not going to be super picky about that, as long as you identify where it levels, and again, that last one in the equation really helps you out with that one. You can always look at the graph. If they're going down, it's a decay, and your x and y intercept. Okay, last example. So this graph, again, there's a slight thing with this. That's a little bit different. I'll just talk about it here first. Notice now in the exponent, there's now 2 things, just x. When you start typing stuff in, the way Desmos is programmed, and you can kind of see how I type it here. The way Desmos is programmed is it's only expecting one thing in the exponent. So let's get out of this for a second. Okay. So if I just type 3, then shift 6x, and then I start typing my +1, it'll actually kick it out of the exponent, because the way Desmos is programmed, it's only expecting one thing as an exponent. So the way we get around that, so we can actually type in the whole exponent, is you have to put in your own parentheses when you type that in. Because if you put a parenthesis in front of the x, then it's expecting more things. And then you close that parenthesis, and then you can type the -2. Okay? So again, if you ever have more than just x as an exponent, and there's not a ton of those, just throw some extra parentheses in that exponent to get those things to show up. And again, highlight your points, get the leveled area, get the jumped up area, highlight your points, get the x and y axis in there for our snip. That's where my snip is. Again, I'm going to write this in here too. So in order to graph, when there's more things in that exponent, put parentheses around it in order for that to graph. So that's part A. Part B, domain, always all real numbers. Range, always Y. And most times it's a greater than. I'm not going to be super picky about that. So if you put greater than every single time, it's fine. And then where it levels out at, okay? So this graph's leveling out down here. If you look at that value, -2, also from the equation. Is it growth or decay? So we have to follow along that graph. It's leveled at first, but it does jump up, so that is a growth. And then we have our x-intercept. This one we have one. We're going to list that out. So we have -0.369. And then the y-intercept is at 1. So that's our last example. I'll give you a second to look at that. So I'll go ahead and post this along with a copy of the notes, and there'll be a little assignment with, I think, of just a few graphs. I think 6 graphs is what I decided to do. Again, if you have any questions, shoot me an email. I will put links on Classroom when I'll have hours that I'll be available online. So I'll either do like a video chat through something called Zoom, or you can just email me. We can use Classroom, email, whatever. I'm here to help you as best I can. I really miss you guys. I wish we could be just in normal class, but thanks for watching, and I hope we can see each other soon.